because Chapter 3 is finance. We try to get a lot of the algebra out of the way at the beginning of the semester because that's the hardest part of the class for most students is the algebra. So we're getting close to being done with that. Probably in about 2 weeks we'll be more into some other things that are a little bit less algebraically intense. Okay?
Did you do this one?
What's that?
The last page?
No, I'm bypassing that one. I meant to take that off. I didn't put the shortened file on there. Okay, so let's see. What we're going to start looking at is a system of equations in 2 variables. And what we'll end up looking at on this is just what we mean by a system of equations, all right? Okay, so first of all, what a system of equations is, and we'll be working on this the next couple weeks in class, is you have 2 equations with the same 2 unknowns in it. So I've got, 2 equations and 2 variables. Okay, so what we're going to do is just the first thing is real simple. We want to see what a point is. It turns out when you have a system of equations, the answer is a point if there's an answer at all. So what you want to do is you want to write this down. Okay, first of all, just write down the first equation and then just plug in the answer. I gave you 6, so the 6 goes in for x. I gave you -4, that goes in for y like that. Okay, and then we're just going to see if it works or not. Okay, so it's easy arithmetic. So then you would have 9 times 6 plus 13 times -4. Work out the arithmetic and see if it's 2. Well, 9 times 6 is 54. 13 times -4 is -52. So that's equal to 2. Okay, so that means that it checked in that equation. So it has to check in both in order for it to be a solution to the system. So that's only half of the problem. Next thing you need to do is take the second equation, -3x minus 5y equals 2, and then plug in. Same thing, x is 6, that goes in there. Y is -4, that goes in there. See if it works. Okay, it's got to work in both. So this would be -3 times 6 minus 5 times -4. Work that out and see if you get 2. Okay, so this is -18. This is 2 negatives, so that's plus 20. -18 plus 20 is 2. So it checked in both. That means the answer to this problem is yes. So it's got to work in both in order for it to be a solution to the system. Okay, we're going to see some kind of important applications for business students to know about systems of equations. We'll get into that a little bit next week after our test. So that's how you tell if that's a solution. Basic arithmetic, okay? All right, let's do the next one. The next one's easier, okay? The arithmetic's less intense. So again, I'm going to take the first equation, and I'm going to plug the point in. The point is 3, 7. What comes first is x. What comes second is y. Okay, so it looks like that checks. That's just 3 plus 7 equals 10. So that checks. Okay, it works there. Okay, now we got to try the second equation. The second equation is x minus y equals 5. Okay, again, plug the 3 in for x. Plug the 7 in for y and see if it works. Okay, so this now would be 3 minus 7 equals 5. Does that work? No. So that means the answer to this problem is that is not a solution. So it's got to work in both equations in order for it to be a solution. If it doesn't do in one, it's no, automatically. That's how you check the answer to a system. That's different than just having one equation with one unknown. You got to check both equations. Everybody with me there okay? Okay.
This will be on the test, right?
No, this is not on the test, okay? This is stuff that will go to test 2. Okay, we're going to get to this kind of next time. But we got to get through this today. We have to. Okay, I don't feel like I have any choice. Okay? All right? Okay, so the next thing we're going to look at is solving a system by graphing. Okay, and so what we're going to do on this, now this is something that we've learned how to graph, so this certainly would be reviewing something you would need to know for your test, but you don't have to know anything about system of equations until test 2. Okay? All right, so what we're going to do is we're going to do a graph of each one of these equations. Okay? If I want you to graph these, the best thing to do is to solve your equation for y so that it's in the mx plus b form where you can figure the slope, figure the y-intercept, and then graph those two like this, okay? All right, so what I'm going to do is solve this equation for y. That means I need to move the x to the other side. So I get y equals negative x plus 7, okay? So that's just solving for y. That's pretty easy on that problem, okay? All right, can you tell me what the slope is now that we've solved it for y? Negative 1. Okay, the slope is the number in front of x. Okay, can you tell me what the y-intercept is? 7. Okay, that's good enough, just 7. Okay, now you do need to know how to graph, a line for next week's test for sure. So when you graph this, what you're going to do is you're going to start at a y-intercept of 7, put a dot there. Now, if you have a slope of negative 1 over 1, how do you count it out? Down 1, right 1. Exactly. Rise over run. So that's going to go down 1, right 1. And you want to do this over and over again. You don't want to just do 2 points. You want to go as far as you can. So from that y-intercept, I'm going to go down 1, right 1, and keep doing that. Just keep going down and over, down and over. Okay, to me, on these kind of problems, it's real important that you just keep plotting that out like that, okay? Then you can connect a line through like that. But it's important to get as accurate as you can when we're doing these problems. Okay, now being able to graph a line, like I said, you got to know that for Monday's test. Okay, not the system thing. Okay, does anybody have a question about what I did? Okay, what do I need to do on the second equation? What's the first step? Move that 2x to the other side. Good. Okay, we're solving for y, so you would have y equals 2x plus 1. Okay, that's it. See, these examples here are pretty easy to do. What's the slope? 2 over 1. You want a slope to be a fraction. So your slope is 2 over 1. What's your y-intercept? 1. Okay. Same idea. So you have a y-intercept that's equal to 1. Okay, that's all it takes to graph this then. I'll just take like a different color here. Okay, first thing you do on this is you put your y-intercept to 1. So your dot goes on the y-axis right there. And how do you calculate a slope of 2 over 1? Up to right 1, up to right 1, over and over again, carefully. Okay, so from that point, go up to right 1, up to right 1, up to right 1. That's good enough. Okay, I think I got everything accurate there. All right, and then connect the dots like this. All right, do you notice that they crossed? That's the key. Okay, so the answer to this system of equations is where they cross. So once you get that graphed out, then you got to tell me what that point is. Okay, what is this point right here where they crossed? What does it look like to you? 2, 5, right. Okay, it has an x value of 2, has a y value of 5. So the solution to that is 2, 5. Okay, that is the solution to your system. Now what I want to show you on this problem is how easy it is to tell you're right, because if you don't understand how to tell it's right, then you don't understand the problem. So what typically is going to go on here is the first equation is x plus y equals 7. Well, x is 2, y is 7, or no, y is 5, so 2 plus 5 is 7, so that worked, didn't it? Okay, so that's good. Take the second equation. The second equation is negative 2x plus y equals 1. X is 2, y is 5. See if it works. That would be negative 2 times 2 plus 5. That's negative 4 plus 5. That's equal to 1. Okay? And you don't have to write down the checking if you don't want to. You just need to know how you check it. So when you get that intersection point, make sure it works in both equations. If it does, then you have successfully completed your problem. Okay, does that make sense to everybody? Okay, is everybody okay with the graphing and how that goes? That's the skill that's required in doing these problems, is you have to graph good. Okay, any questions? Okay, we're going to do a couple of these because there's a couple of things that can happen. There's actually 3 possible things that can happen when you graph 2 lines. Okay, so that's how you would start that. Okay. On part B, we're going to do the same thing. Okay, we're going to just write down your two equations. We're going to solve for y, and then we're going to graph, and I'll kind of show you what happens on this then. Okay? All right, so these are fairly easy. What you do on the first one here is just move the 2x on that, so you would get y equals negative 2x plus 4. Okay, so that means the slope is negative 2 over 1. The y-intercept is equal to 4. Okay, so just like the last problem, solve for y, complete your graph. Okay, so we're going to do that. So go ahead and do your graph. You have a y-intercept of 4. If you have a slope of negative 2 over 1, you're going to go down 2, right 1. Okay, and just do as many dots as you need to. So from that point, down 2, right 1. Down 2, right 1. And you never know where they're going to intersect. So it's a good idea to just put several of those on there. Now I'm just going to put that on there. Then I'm going to graph my line like that. So that's my first line like that. Okay? All right. When we do the next one, we're going to do exactly the same thing. There's going to be a lot of similarity in this graph. Move the 2x over like that, so you'll have y equals negative 2x plus 6. What's the slope of this line? It's the same as the last. That means something. That's significant. What's the y-intercept? 6. Okay? So now we got what we need to know, so you want to go ahead and construct that graph and see what happens. So you'd have a y-intercept at 6. So you put a dot at 6. Then you're going to go down 2, right 1, down 2, right 1, down 2, right 1. Okay, I'm going to ask you a real simple question. If that keeps going down 2, right 1, are they ever going to cross? No. That's what matters on this problem, is those two lines are never going to cross. Okay? We call those parallel lines, and since they don't cross, that means there is no solution. Okay, the only time that you can have a solution to a system of equations is if the two lines cross, like they did in the first example. That's it. Does that make sense? So you will never find an x and a y that will work in both equations at the same time. And it's actually, you know, to me, tell me if this makes sense to you. If you picked a number for x, if you did 2 times x and added y and got 4, would it ever work if you did 2 times the same number plus the same number and get 6? No, it's impossible, okay? There's no x you could ever find or y that would make that work. So that's the idea. All right, so if your graphing is solid, you won't have trouble with this, what we're looking at here. Is there any question about that with graphing primarily? Okay, so you're looking for where they intersect, or if they don't intersect, there's no solution. That's what you'll find, okay? Okay, so I'm going to let you work on the next two, and I'll come around if you need some help. The key thing that I see on this from students is not solving for y correctly. But this is important that you guys can do these graphs okay, because you will have to do graphs on next week's test. So just go for it. Let me come around and I'll help you a little bit if you need some help. I would always start by solving each equation for y, finding slope and y-intercept, and then taking it from there. I suspect what you're going to see, I haven't worked them out, but I suspect one of them will cross and one of them doesn't cross. Let's probably what I tried to design there. So I'll just kind of walk around and see what your graphs look like. I can tell if you understand this or not based on how your graphs are looking. I'll make sure those lines continue to go, okay? So I mean, they're going to continue to go on forever. So that one looks like it's going to cross somewhere. You got to figure out where it crosses. Okay? Just do one line at a time. So did they cross on that first one? Okay, you down front. Yeah. It looks like negative one. Yeah. And see, and how you know how I got that? I was seeing that your answer was right. So if x is negative one and y is negative one plus negative one is negative. Yeah, I did graph. Yeah, okay. So your graph has to be right on that. So you take that one, continue on with those. And see, the one thing that's helpful on this is if your slope's 4 over 1, yeah, you go up 4 over 1, but you can also go down 1 and over. So the opposite of up and over is down and over. So you want to be flexible and try to get as many points on those as you can. Okay, that looks good. That looks good. Oh, that's good. You're good. You're good. Okay, that's good. I see one thing it'll check.
I did.
Okay, good. Yeah, that's right. Okay, you want to close off the deal by making sure it's right. Okay, you're doing good. You got that? Now that was, I think you're off on that one a little bit. I think what you want to do, you got off track a little bit. This one one of them had a slope of 4, right? So you could go up 4 over 1, but the opposite of up 4 over 1 is down 4. 1, 2, 3, 4, and left 1. So that you should have made it through that one. Okay. So you got off track there a little bit.
Was it just like if I drew the line with the ruler?
Yes, you probably would be fine if you did that. But I say if you have a slope of 4 over 1, be flexible. Up 4, right 1. The opposite of that's down and left. Okay, so I think I'm seeing that with some students not quite catching on to that. Let's see, your answer wouldn't check on that. I think you get -1 now if you look at that, okay? You got everything okay? You have trouble with your graphing? So you saw for y correctly, so that has a slope of 4 and a y-intercept of 3. Let me see your pencil to get you started on that. So that one you have a y-intercept of 3, so it goes there. That's the y-intercept. If the slope is 4, you go up 1, 2, 3, 4 over 1. I see you put a dot there, so then that line would go through like that. That's it. Okay. It just takes 2 different points to get that line. Okay, you did that okay. You're on the right track, I think. So how many people got -1 for the first one? Okay, what happened on the second one? They were parallel, is that what you guys are getting? Okay, so the first one's -1, and then the second one's parallel. Okay, so I'm just going to do this real quick. I think most of you got through that okay. So this is 4. There's something I want to show a lot of you on this, though, too, is on this first line, you have a y-intercept of 3, and you're going 4 over 1. Be flexible on this. This is why some of you missed it. You go 1, 2, 3, 4, up and 1, but the opposite is down 4 and left 1. So you could also look at this as down and to the left. So I can go 1, 2, 3, 4, and down like that. Okay? You want to be able to count your slope both ways, one way and then the opposite way like that. So that's how that first line goes. Okay, the second one, you would move the x over here. So you'd have y equals -x minus 2. So on this one, the y-intercept is -2. The slope is -1 over 1. So at this, you would go left 1 over 1, left 1 over 1, but then go backwards. The opposite of down and left is up, or I'm saying that wrong. The opposite of down and right is up and left. So you go like that, and then that's how your line goes. So the intersection point is -1, -1. Okay, looks like most of you got that. The only thing I saw on that was maybe not counting backwards on that. You got to either take a ruler and get it real straight, or be able to be fairly flexible in your in how you count out your slope. Okay, over on this one, you would move the 6x, so we'd have negative 3y equals negative 6x plus 3. Divide by negative 3. Okay, if you did this correctly, you would get y equals 2x minus 1. So that's how that goes. You want to make sure you did that okay. This has a y-intercept of negative 1. It has a slope of 2 over 1. So from that point, you would go up to right 1 a couple of times, and then that's how that first line goes, is like that. Can't mess up on solving for y, or you're not going to graph right. I can see on this one where students would kind of slip up on a negative. On this equation, I moved the 2x, so I would have negative y equals negative 2x plus 4. Now, what do you got to do next? I can't have negative y. I got to have positive y. So what do? Divide by negative 1. Good. Okay, so you want to take this one, divide both sides by negative 1, and you would end up getting y equals positive 2x minus 4. Okay, you got to check how that arithmetic goes. You have to divide by negative unless you move the y to the right side, which you can do it that way too if you want to. Okay, so what would happen on this one then? Your y-intercept's negative 4, so I put a dot there. The slope is the same, that's the point. So if you go up 2 over 1, they're never going to cross. So your lines should have looked like that. So that one is no solution. Okay, like that. So those are two of the possibilities that can happen. The other possibility is the two lines could be the same. They wouldn't look the same in the original problem, but they could turn out to be the same. I'm not going to worry about that case so much. Okay? All right, so that's the graphing aspect of that. If you have your graphing down on that, that won't be too hard for you. Okay? Okay, now I'll say this. This is the worst way to solve a system of equations. We're going to learn other techniques, and we're even next week going to learn how to just put this in your calculator with something called a matrix and get the answer like boom, boom. Okay? So the graphing is to help you understand the geometric meaning of a system of equations. Okay? But you want to know how to do this, but in practice, it's not the best way to solve a system of equations. Okay? A better way is to do substitution. So that's what I'm going to look at on the next page, and then we'll focus on elimination. Okay, so we're not going to graph these. The reason graphing is the worst way is because sometimes your point is fractions and decimals and you can't figure it out. Okay, you can always figure it out this way. All right, so what you do on this, the first thing you look for is you like it if one of the equations is solved for a variable. So notice on this one that this is already solved for y. You like that. We call it substitution because what you're going to do is you're going to plug that in to the y of the other equation. Okay, we call it substitution for that reason. Okay, so what we do is what you want to write on your paper is start by writing down the top equation. Just write it down. It's 2x plus something equals 11. Don't put y there, put just a blank bracket there. What we do is we substitute one equation into the other equation. Okay, so what goes there is going to be the 3x minus 9. Okay, so again, all I'm doing is taking 3x minus 9 and plugging it into the other equation. Does that make sense? Sometimes students don't see that if they've never seen that before in their life. Okay, that's why we call it substitution. Plug one thing into the other. Okay, now you can solve this equation. This is the kind of equation you've done this semester. So we're going to solve the resulting thing. It only has one variable now. So notice 2x plus 3x is 5x. Minus 9 equals 11. And then solve that, and that'll give you what x is. Okay? So this one we can add 9 to both sides. That'll give 5x equals 20. You can divide both sides by 5. So you'll get x is equal to 4. Okay? So the first part of the solution is x is equal to 4. So once you substitute, then it will be a basic equation that you have plenty of experience in solving. So that's it. Does that make sense? Okay, does everybody see how that's substituted? Okay. All right, next step, there's two steps to this. The next step is find y. Okay, so what you got to do is you pick an equation. It doesn't matter which equation you pick, but just plug the 4 into it. I would probably pick this one because it's easier. That's my thought process. So what we're going to do is, now that we have x is 4, just plug it in. Okay, so what we're going to have is y equals 3 times 4 minus 9. So just plug it in and calculate. Okay, so that's going to give y equals 12 minus 9. So that gives y equals 3. Okay, so what you're finding is the value of x and the value of y like that. Okay, that's how you put that together, is substitute one equation to the other, solve and do that. Now to check, you really want to verify that it works in both equations. You don't have to write the checking down, but you want to know it. The first equation is 2 times x plus y equals 11. Okay, x is 4, y is 3. That's 8 plus 3, that's equal to 11. It's not hard to check until you're right on these problems. Just take an equation and plug it in. The second equation is y equals 3 times x minus 9. Okay, x is 4, y is 3. Okay, you don't have to write that down, just pay attention to this and understand this. That would be 3 equals 12 minus 9. That works also. So it's the right answer. Okay, all of these problems are 100% verifiable by checking. Does that make sense? So why in the world wouldn't you check? If it's verifiable, then do that. Okay, that way you'll understand what you're doing better anyway. Okay? Okay, next problem has a slight twist to it. Okay, so what you always want to do with this is you want to look at your two equations. This is your first choice. You want to solve either equation for either variable, but you want to do this the easiest way possible, if it's possible. Okay, if you do the first equation, what's the easiest variable to solve for in the first equation? Y. How come? There's nothing in front of y, so you just slide that over there and be done with it. In the second equation, you wouldn't want to solve for y. You'd start getting a bunch of fractions. I mean, you can do it that way if you want to, but you want to keep this as simple as possible. So what I suggest is, if this pops up, is if you see a variable with nothing in front of it, that's how you want to start the problem. So step one, what you want to do is write down the equation and solve that for y. Okay? All right, so that just means slide this over like that. So you would get y equals 1 plus 3x. Okay, that's step one, is get one of the equations solved for a variable, but keep it simple. Okay? Step two, you want to work with the other equation. So write down the other equation, but where you see a y, don't put y, put a set of parentheses, because we're going to plug something into it. Okay, but you want to just get that written down like that. All right? Okay, so what you do next here is y is 1 plus 3x. Okay, so plug it in. Okay, that's going to go in there. So just like the last problem, you plug it in. All right, does that make sense? Tell me. I can't tell. That's why we call it the substitution method, is because you're substituting one thing into the other equation. Okay? Now see, that equation has one variable. So you should be able to pretty easily solve that for x. So now you're just going to solve for x. You guys have been doing this all semester. So distributive property, that would be 4 plus 12x minus 12x is equal to 3. I love the way this problem's working out. This is the easiest problem to do. Okay, so look what happens. What do you see happening?
4 equals 3.
What? X's cross out, and when this happens, it makes the problem way easier. What are you left with? 4 equals 3. Okay, now what we did when we graphed, there was two possibilities. When we graphed, they crossed, or they were parallel and had no solution. What do you think? No solution. That's ridiculous. 4 equals 3 is what we would call a contradiction in math. So since those things are not equal, we would say there's no solution. So anytime that happens, then the problem's a lot less work. Okay? So either of those two things can happen. If you get the variables canceling out and get something that's false, it's no solution. Otherwise, if you get a solution, that's like the example 1. Okay? So let's try to do one of these and see how you do. On this one, let me just kind of talk about what you want to recognize in this problem. Okay, first step is to pick an equation and solve for a variable. What do you notice? It's already solved for a variable, right? So what are you going to do? You're going to plug that x plus 3 into the other equation. Okay, go for it. See if you can finish it up. Okay? I never can tell if you know what I'm talking about unless I walk around and see it. I think this one will have a solution, I'm pretty sure. So you gotta work it out. But the arithmetic in this problem shouldn't be too bad. That's what I got. Okay. That's your own red track. Yep. Okay. Now you got to find the other variable. Okay, that's good. Okay, except that's 2x. X plus x is 2x. You'd have two. You're not distributing. You're collecting like terms. See, that says x plus y. So x plus x is 2x. You would have 2x plus 3 equals -5. Not multiplying, it's x plus y. Let's see what we're getting back here. You got anything? That's what I got. Okay, that's good. Okay, you got the same thing? Okay. Okay. You probably need to come talk to me. Okay, that's good. Yeah, I'm not going to do that today. I'm going to need to teach. Okay. Got everything okay? That's good. Okay, except that would be -4, because then you divide by 2. Okay? Got it okay? All right. Okay, good job. I don't see hardly any issues on that. Okay, so this one you have x plus y equals -5. So I can see that we got the substitution part down. That plugs in there like that. These are like terms. X plus x is 2x plus 3 equals -5. Subtract 3 from both sides. You're going to have 2x equals -8. Divide by 2, you're going to have x equals -4. Okay, we've got that. Now, to find y, you just pick either equation. I would pick this one just because it's easier. And then now that you know x is -4, plug it in. So you'll have -4 plus 3 is -1. So your answer is -4, -1. Okay? The arithmetic on that problem wasn't very hard, so there wasn't a lot of room for a lot of arithmetic errors on that. So that one should go pretty smooth. Okay, looks like you did a good job. Okay, looks like we're doing okay. Okay, we're going to go through and we're going to do elimination. And I'll show you how to do elimination. This is probably the most common method that you're going to do is the elimination method. Okay, so I want to kind of get you through how to do the elimination also here. Okay, so let me show you this. And when we do this, guys in the back, please, hey, please, hey, please. Okay? Yeah, please. While I'm teaching, you can't do that. Okay? Okay? And you really need to take notes instead of work on your homework in here. If that's a problem for you, come talk to me. Okay? Okay? Because you gotta follow along. You just do. All right, write down the system so I can show you what happens on this and why we call this elimination. Okay, so we have 2x plus 3y equals 20. Then we have -2x plus y is equal to 4. Now what you do when you do elimination is the first thing you look for is you try to add up your terms. Okay? So what do you notice if you added up 2x and -2x? Don't those things just cancel? Yes. That's what you want to happen. That's why we call this elimination. So yeah, just add it up. Just kind of draw a bar under there and add it up. That goes to 0. And see, this is 3 plus 1, so that's 4y. You want to just add the equations together. And then 20 plus 4 is 24. Okay, if it works out this way, this would be the easiest example. Now you would divide both sides by 4, so we get y is equal to 6. Okay? All right, so in our answer, we have y equals 6. Okay, that's the easiest possible thing that can happen on the problem. Okay, now, second step after you do that is you want to pick an equation and you want to plug it in. It's up to you which equation you pick. You'll get the same answer regardless. What I'm going to do is, because it looks easier to me, the numbers are smaller, is I'm just going to write down the second equation, negative 2x plus y equals 4. Okay? And what I'm going to do here is I'm going to plug in, okay, like that. Just plug in, and then you'll have another equation that's pretty easy to solve. Okay? So if I do this, I have negative 2x, and now you have plus 6 equals 4. Okay? All right, solve the equation. All right, so what we do here is just subtract 6 from both sides. Okay, that's going to end up giving me negative 2x equals negative 2. Divide both sides by negative 2. So it looks like we get x equals positive 1. That's your answer. Now that's the simplest type of elimination problem is going to be something like that. Something already cancels from the beginning. Okay, so when I do that and add the equations together, I'll be having one equation with one unknown in it, kind of like that then. Okay? All right? How would I check and tell I'm right on this problem? Plug it into both equations and see if it works. I'm not going to do that on these problems, but it's always there for you to do. Okay? All right. Problem B is a little bit different. So go ahead and just write it down. Write down the system. So you have x plus y equals 10. Then you have x plus y equals 6. Okay? Now, you don't need to write this down. I just want you to write that. Or just look at this. Okay? If you added these equations together, you would get 2x plus 2y equals 16. That is not what you want to happen. You want to make one of them eliminate. Okay? So it turns out if you want to make something eliminate, well, if this is a positive x, you would like that to be a minus x, right? That's what you want to happen. So since you want that to be a minus x, you can do this. You can multiply the second equation by negative 1, and you got to do both sides by that. Okay, and that's what you're going to kind of learn to do on this, is if they don't eliminate immediately, then make it happen. Okay?
So what do you call that? You subtract terms or what?
What's that again?
Would you say you're subtracting terms, or what are you doing?
Well, I'm really collecting like terms, and I want them to cancel. So the idea I was kind of showing you is you really were kind of wishing it was x and minus x. So I'm making that happen by multiplying the second equation by negative 1. Because you can multiply both sides of an equation by the same number. Okay, that's why I'm doing that. Okay. Now what you do is just write down the top equation again. Okay, it's not going to change. Now the second one changes. You would have negative 1x minus y equals negative 6. So all I did was really change the signs on the second equation. Now this is the simplest problem that can happen on this too. All right, what happens on the left side? What do you see? Nothing. Everything cancels. Now I see this all the time from students. There is something there. What is there? It's a 0. If everything cancels, there's a 0. And that's important, okay? This side is 4. All right. So remember when we did graphing, we learned two things. If they intersect, you have an answer. If they don't intersect, you don't have an answer. What do you think on that? That's no solution, okay? Anytime that the variables cancel out and you get some ridiculous statement, that's not true. 0 and 4 are not equal. You like it when that happens because it's easy. That means if you solve that problem by graphing, those two lines are parallel, okay? That's what's always going to happen, okay, on that kind of case. Right, so that's kind of the basic idea we're getting at. Is there any question about why I multiplied that second equation by negative 1? Okay, that's what we're going to get to here, okay? All right, now I'm going to do a couple of more of these because I want to go through little nuances that happen on these problems, okay? All right, so again, write down your system, okay? So the first equation is 4x minus 3y equals 12. And then we have x plus 2y equals 14. Okay? Now, the first step is your choice. All right, we want something to eliminate. Here's the way I look at this. If that's a 4, what would you like that to be? -4. That's the easy way to do it. Now, that's a -3. Kind of hard to turn that into a -3. But you could turn those into 6s. You could make that -6 and 6, but I wouldn't bother. If I want that to be -4, what do I do to this equation? Multiply by -4. So you take advantage of the fact that you can multiply both sides of an equation by the same number. Okay? So we're going to multiply both sides. Be sure you do both sides by that. And when you do these problems, be neat about keeping your system together. You should always just write down that first equation again. Now in your head, you're going to do a distributive property. So that is -4x and then -8y equals, and I think that's -56, I think is what that is. You can use your calculator on that. Okay, so we have that. All right? So that's the whole key on that, is to get that kind of put together. Now, what will happen is when you add the columns together, that cancels. Okay? The next one is a -11y. Just double check all your arithmetic. And then if I go through on this, you can do a calculator if you wanted to. You could go 12 minus 56. And that's -44. Now, these problems can have fraction answers. For practice, most of them are going to have whole numbers. So what do you do to solve this equation? You divide by -11, okay, like we've learned. Okay, that's going to give y equals +4. Okay, so we got the y value, so in our point of intersection, we got 4. This is going to be two lines that intersect, essentially. Okay, so that's step 1, is to do that elimination process. Step 2 is you have to find x. So what do? You pick either equation and plug in. To me, the easier equation is the second one. It's got nothing in front of x. I kind of like that, but it doesn't matter ultimately. So I'm just going to write down the second equation. I know that y is 4, so I just plug in the 4 in for y, and then I can find x. Okay, so I'll have x plus 2 times 4 is equal to 14. So I have x plus 8 equals 14. Then I can subtract 8 from both sides. So I get x equals 6. Okay, so once you get that first answer, plug it into an equation and solve. You have to have your equation solving skills down very well to do these problems effectively. So that's 6,4 would be the solution. That would mean where those two lines intersect. Okay, is there any problem with that? Okay, all right, let's do one more. Okay, so again, let's just write the system down. This is the other thing that I can think of that could happen on the problem. Okay, sometimes you have to work with both equations. Okay, so you're not going to make both of those 5, but you can make both of those 15, can't you? Okay, same thing here. You're not going to make both of them 3. What can you make both of them become? 6. It's kind of like a common denominator. It's the same thing. So what I want on this, and this is what you got to understand, is I want this part right here. I really want that to become -6y. I want the negative there. I want one of them to be negative and one of them to be positive. This one right here, I really want that one to turn out to be +6y. So sometimes when students are learning this, they wonder, how do I know what to multiply by? Well, here's the thought. What do you do to this to turn it into that? Multiply it by what?
2.
By 2, right. Okay. What do you do to 2 to make it turn into a 6? Multiply by 3. Okay, so you have to figure out what to multiply these things by. Okay, so what we're going to do on the first equation is we're going to multiply both sides by 2 there. The second equation, we're going to multiply both sides by 3. You'll know if you're doing this wrong, okay, in the next step, because something isn't going to cancel out. Okay, so now we just do this in our head. So do a distributive property. That would be 10x minus 6y equals -2. And 3 times 3 is 9x. And then plus 6y equals 21, like that. Okay, now they're going to cancel out. That's why we did what we did. Now it's pretty simple to finish up. The y's cross out. 10 plus 9 is 19x. Negative 2 plus 21 is 19. Okay, you can solve that in your head. So we get x equals 1. So that's your first part of your answer is x in your point is equal to 1. So we're going to get a solution on that. Okay, what do I do next to close off the deal? Pick an equation, right? I pick an equation, and then it doesn't matter which equation you pick, and then just plug in. I'm going to pick the second equation because it doesn't have any negatives in it. That's my thought. So 3x plus 2y equals 7. Okay, and then we got that. Plug in the 1, and then you should have it. So we'll have 3 times 1 plus 2y is equal to 7. So that would be 3 plus 2y equals 7. Okay, subtract 3 from both sides. Got 2y equals 4. And then divide both sides by 2. So you get y equals 2. Okay, so the answer to that problem would be the point 1, 2. Okay, the one that you're going to use the most often is this, elimination. That's the one that usually is the simplest to do. Substitution, you kind of use that when it's set up for that. Graphing, you're really never going to do it that way. That just helps you understand that the solution is where the two lines intersect. Okay, does that look like stuff you did before, maybe?
So it doesn't matter which one we choose, they
No.
both will work?
Both work.
Okay.
It's an absolute guarantee. Okay, so just take your pick. Okay, study hard for the test over the weekend. I've given you a lot of good stuff to study. You can use a note card, so bring it in. I checked your note card and everything. And what's that?
What's your schedule for tomorrow and Friday?
I'm not here Friday. Let's see. Tomorrow I'm here a lot. So if you need help, come by 12 to 2. You know, I'm in my office 12 to 2, and I'm in the math lab 2 to 3. Okay? So just if you've got anything that you need to kind of brush up on, you can do that. Come in and let me help you a little bit.